बेटा। So let me open my paint screen and try to explain you all the internal working of a hash map. This is very frequently asked interview question, the internal working of a hash map. So what happens is, whenever you try to insert into a hash map, okay, and you have to pass the key and value. So we specify the type of the key and type of value over here. So let's say I am storing their name and age. So I will store their name as key and age as the value. And directly we can give over here like this. So when I try to add something to the hash map, the key and value, how internally it is stored into a hash map is, first whatever key I have entered, because key have to be unique. Keys have to be unique. So whichever key I am entering, it will first take the key. Okay, so see what it does. So let me just take one example at the moment. Let's just take this example. So when I try to put a element into a hash map, it will take the key of that element and it will generate a hash code. Okay, so we have a function in the object class hash code. So it will generate a hash code for this key. So it will generate a hash code. So whatever hash code is generated for this key, let's say the key was 12345. Let's say this hash code got generated for this key. Now this hash code is then passed through a hashing function. Okay, so normally it is mod by the size of the mod by the capacity of the hash map. This is the hashing function, mod by the capacity of hash map. So now if I don't provide any capacity, let's say I pass a capacity of 10 over here. When I create this hash map, I pass a capacity of 10. So now this hash code will be given to this hash function, which will calculate mod with the capacity. So capacity is 10. So anything mod 10 gives the last digit. So 123 mod with 10 will give you the last digit 5. So what it does is, this hash map now has 10 buckets. This hash map now has 10 buckets. So whatever the capacity we have given, it will have those many buckets and they will be indexed 0, 1, 2, 3, 4, like this. They will be indexed like this. Let's see. So these are the indexes of that bucket: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So as the size is 10, we have buckets from 0 to 9. So whatever is the output of the hash function, that is the bucket index. That is the bucket index, and this object now will be stored over here. So this object Alice will go to bucket index 5. Next time when I try to enter anything else, dot put, and I try to enter the key value pair. So what it will do is it will take the key first. This key is then fed to the hash code function, and the hash code is derived of this key. Let's say the hash code was 56743. This was the hash code. Now this hash code which is generated of the key is sent to the hashing function, which is mod with the mod capacity of the hash map. So 567 mod with 10. 56743 mod with 10 will give me 3. So it will store that object at that bucket. Okay, so first all these will be null. First at the start all these values will be null. All will be null. So this is the level of concurrency. This is the level of concurrency the hash map is maintaining. Initially all the index will have values as null. Now it will tell which bucket, bucket number 3. So this object which is there will be stored at bucket number 3. Okay. Now there can be a collision. Now what do I mean by a collision? There may be some key. When I try to generate a key, so when I take the key and calculate its hash map, its hash code, it might give me this 56495. So which I mod with 5, which I then mod with 10, that is the capacity, will give me 5. So this will also go at bucket 5, but at bucket 5 there is already one record existing, so it will do a chaining, so it will form a linked list. So it will store this record at a location. Let's say that location is 1000, and now this 1000 will be chained over here. So this Alice object will be there, and it will give a chain as to where the next object is, and like a linked list it will behave. So next object is as 1000, so it is linked over here. So this is how your hash map manages the collision. Okay, so now if I try to add one more element into the hash map, so it will take the key of the element, derive the hash code of that key. Let's say that key hash code is 56795, assuming, or 35, whatever. So this also will go at, will give me 5. This also will go at that key. So it will first check whether there is an element with this key over here. So it will compare the keys. Alice with Dom, is the key same? No. Is the next null? No. So we'll go to 1000. We'll compare the key. Are the keys same? Is Chris and Dom same? If not there, then it will go and add to the key. Then it will become a part of the queue and it will get address as 2000, and this object now will, so every as it is a linked list, as it is a linked list, every object will have a portion of the pointer also to point to the next node. So here it will point to the next node, which is 2000, and then this will be linked over there. So it will always compare with all the keys in that bucket. So this comparison is in the time complexity of O of n. So this comparison is in the time complexity of O of n. Okay. Now, if I try to add one more element, let's say, if try to add Ben and 29 years. Okay. I try to add this key now. I try to add this record, Ben and 29. So it will first go there. So every object has a different hash code. Okay. So it will take Ben. Let's say it derives a particular hash code. Okay. 56743. Let's say it has got two objects can have the same hash code if they have the same value. So now this will also go to which bucket? 56743 mod with 10 will also go to 5. So now before going, I will check whether this key already exists. Whether this key already exists at the bucket 5. Does it exist? No. Does it? Okay, this was given to 3, right? Okay. So the Ben was going into 56743 mod with 10. So Ben is going at bucket 3. So now I will check at bucket 3, is there an element existing? If it is existing, I will replace it over there. Will not add a new one. So this is how your hash map works. Okay, and this hash map can be synchronized, means if some thread acquires a lock on this hash map, what it does is it locks the entire hash map. The lock is given on the entire hash map. So if now thread T1 is accessing this map, thread T1 is accessing, and thread T1 is working on, let's say, bucket 3, but it will lock the entire hash map, even though if it is working on one single bucket. So now this will slow the performance of the application. So they introduced one more class called as concurrent hash map. What they did, introduced a new class called as concurrent hash map, What this concurrent hash map does, the number of buckets, that may number of locks. So you can have multiple locks. So if the level of concurrency is 2, if the level of concurrency is 2, then I can have 2 locks granted at the same time. So I'll split it to half, and I can say one thread can work on this part. So this is my level of concurrency. So depending on my level of concurrency, if it is 2, then I can have 2 threads working simultaneously on this hash map, on this concurrent hash map. One can work from one can log bucket 0 to 4, and other can log bucket 0 to 9, 5 to 9. If I have, let's say, level of concurrency as 5, level of concurrency, if I have equal to 5, so now I can have 5 different threads working on this hash map. So one will work on this, one will work on these 2 buckets, one will work on these 2 buckets, one will work on these 2 buckets, and one will work on these 2 buckets. So now if a thread has come and acquired the lock on this bucket, so that thread will only lock this much portion. So now I can have 5 threads running parallelly and accessing my hash map at the same time. So they are each working on the different bucket. So this is what concurrent hash map has been introduced for. So in the case of multi-threaded application, don't go for hash map, go for concurrent hash map. Okay, let me see some information for you all on the internet if it is beneficial for us. Okay. Let's try to search it. Okay, so let's say, see, difference between, okay, hash map and concurrent hash map. And let's try to go here. See what it is telling. So try to understand this concept. Okay. Okay. So let's check concurrent hash map in Java. Let's check this. This should be able to explain us better. See, the concurrent hash map was introduced in JDK 1.5. Okay. Is thread safe implementation of the map interface, which means, see, this is what I want to show you all, which means multiple threads can access it simultaneously without any synchronization issues. So that is called as fine grained locking. That is called as fine grained locking. What the hash map was doing, what the hash map was doing, it was locking the entire hash map at once. So this was post grained. Okay, this was post grained. And now what is the concurrent hash map doing? Concurrent hash map is now doing it. So if I have level of concurrency as 10, each bucket can be accessed by a thread parallelly. So I can have 10 threads running parallelly on this concurrent hash map. Okay, so that becomes fine grained. So it's telling it provides a fine grained locking, meaning that it locks only the portion of the map being modified rather than the entire map. which makes it highly scalable and efficient. Okay, so this was the difference between hash map and concurrent. Rest the working is more or less the same. It's just that in which use case you should be implementing hash map and which use case you should be implementing concurrent hash map. So if you are a multi-thread application, then always prefer that you go with your concurrent hash map. Okay, so these two topics are done. Now let's come to generics. Okay, now what I mean by generics is, let me share my code for y'all. Let me share my code.